Welcome all. In the computer communication, today the topic is OSPF. Open Shortest Path First protocol is an interdomain routing protocol. It is based on the link stage routing. This OSPF is mainly used for an autonomous system. That means we have a more than one areas, or it connect for a single area, or you can connect the router to router. These are the majorly used in the OSPF. It will create a path for the source to the destination through the routers, and it will collect the information about the neighbor routers and keep track it information. So below we have seen one diagrammatical representation. It shows about area 1, area 2 and area 0. That's a backbone network. If I want to connect from any one area to the another area, we have to pass the information through the intermediate router. So for this, our OSPF will plays a major role in this. These are the different types of links. The types of links are point-to-point, transient, stub, and virtual. These are the four types of links available in the OSPF. When I am saying it is a point-to-point link, it connects to router without any host or router intermediate. That means a direct router-to-router connection. It's like a point-to-point. As like our we say in the PC, we have a point-to-point connection. As like that, the router it will connect from the one router to the next router directly. It won't have any intermediate step. So within a single hop, it will reach our next router destination. This is we can say as a point-to-point link. The next example is a transient. What we can say as a transient, it is a network of several routers are attached to it. So we have a multiple routers will be available in this. So that way we can say as a transient network. And then unrealistic representation. Here we can see from the each router we have a multiple paths are available to a different routers. The third one is a realistic representation. Here it's designated as a router. It will connect to the multiple routers. So when we am saying it's a transient link, it is a several routers are attached to the link or our network. The stub link, it is a network that it's connected only one router. You can see the stub network, the representation. It will be there is a only one path is available for the destination router. So incoming and outgoing will be through only one path. So that we can say as a stub link. Virtual link. When the link between the two routers are broken, the administrator may create a virtual link between them. So this table it will states about what is their link type, the link identification and link data. When I am saying a point to point, it holds about a address of the neighbor router, nearby router information will be available in this. For this they will use a interface number. Transient, the address of designated router. It will holds the router address. When I am saying it about stub, it's a network address. It will holds the network mask. Virtual address for a neighbor router, and it will holds the router address. This is a simple example of an autonomous system in a graphical representation of OSPF. And you can see here N1, N2, N3 and all network 1, network 2, network 3, network 4, network. So for example, 5 networks are there. So nearly 6 routers are connected in between. So if I want to go from this range to this range, there will be 2 lines intermediate available is there. This autonomous system representation also it's given as a graphical representation. So how we can connect with the multiple routers. So if I want to pass the information from the one area router to the next area router, so we have seen the 4 types of example. So anyway it will in this anyone it will choose and it will follow the path. OSPF common header. This is a header format of our OSPF. It has a version, what is the type, message length, source router IP address, area identification, checksum, authentication type, and authentication. So this is a 32-bit common header format. What are the types of OSPF packet? It has hello packets, database description, link stage request, link state update, link state acknowledgement. When I am saying a link state update, so mostly OSPF we are dealing about a link state of the link, the router link, network link, summary link to the network, summary link to autonomous system boundary router, external link. So these are the various types of the link state will be updated to the nearby routers. For that they will use a OSPF hello packet. And I am saying a hello packet. The OSPF common header 24 bits type 1. The network mask it has a hello interval, ENT, priority, dead interval, designed router, designated router IP address, backup designated IP address, neighbor IP address. So these are the information will be available in the hello packet. OSPF uses the hello message to create a neighborhood relationship and to test the reachability of neighbors. So once we are coming to a network, we are new to the network. So we have to create a former neighbors. So the neighbor will be gathered with the help of hello packet. This is the first step in the link stage routing. Before a router can flood all of other routers with the information about its neighbors, it must first generate its neighbors. If I want to transfer the information to the neighbors, first I have to create my neighbors who are all available my nearby area. First I have to create the list, then we can send the information. Simple, if I want to send some information to someone, first we have to collect to whom and all I have to share the information. Once we collected the details, then we will proceed for sharing the information. Database description packet. It also has the OSPF compiler header. It's of type 2, all zeros, ENB bits, message sequence number, and LSA header. When a router is connected to a system to a first time or after a failure, it needs to complete link state database immediately. Therefore, it sends a hello packet to greet its neighbor. Once the failure occurs, again we have to send a hello packets for the neighbors. If it is the first time the neighbor hear the router, then they set a database description message. The database description packet does not contain a complete database information. It only gives the outline, the title of each line in the database. It won't give the overall information about the lines and everything. The basic details will be first initially shared. Link state request package. It has a OSPF common header. It's of type 3. We have a link state type, link state ID, advertising router. When I am saying a link state type, and what is the state ID? When I am saying a router link, it holds the IP address of the router. When I am saying a network link, it holds the IP address of a designated router. Summary link to the network, it's the address of the network. Summary links to AS boundary means autonomous system. IP address of the boundary router. External link, address of the network. So these are the different link state type. For that each and every type, the description is this. Link state update package. OSPF common header, then type it will be 4. Number of link state advertisement, how many advertisement we are doing. The link state advertisement, any combination of 5 different kinds. Network link, router link, summary link to a network, summary to a boundary or external link. Then we have a link state acknowledgement packet. OSPF common header, it's a 24 bytes. It has a type 5, LSA general common header, and then 20 bits of corresponding type. Link state acknowledgement general header. It has a link state age, and then reserved ET, link state type, link state ID, advertising router, link state sequence number, link state checksum, and length. This is a header format of a LSA acknowledgement. Link state age. When a router creates a message, the value of the field is 0. When each successive router forwards this message, it estimates the transient time and adds its cumulative value to the field. So initially the value will be as a 0. Once I am passing from the one router to the next router, the lifetime of this acknowledgement package will increase. We may not know that how many intermediate hops will be available. So based on the intermediate hop, my age of the link stage acknowledgement will increase. E flag. This is a flag set to 1. It means that stub area. We already discussed what is a stub area. There is a entry and exit. It will be only one path is available, that we can say as a stub area. An area that is connected to a backbone area, only one path. That, say example, you can say as a stub area. For that, we can set a flag to 1. If the flag is set to 1, it means the router can handle multiple types of service. When I am saying it's 1, it can T flag. It is 1 means it can handle multiple types of service. Advertising router. The IP address of the router advertising the message. So with this IP address, it will advertise the message. Then link state sequence number. A sequence number assigned to the each link state update the message. So based on it, you will update the message. This is the different header formats and what are the fields available in a LSA header. So this is all about OSPF. Thank you.